As we edge our way out on the branch of speculation, let's get to the place where the branch may not hold our weight. Let's talk about simulation, a final topic. We'll start with some futurology, designed to show how difficult it is to anticipate the far future or advances far beyond our reckoning. If we go backwards in decades of time to of order 10 years, the internet, of order 100 years, the development of cars and planes, the world rapidly becomes primitive and almost unrecognizable. Going back 1,000 years, we're at the birth of modern medicine. 10,000 years is the beginning of agriculture and civilization. Tools and basic pre-humans, 100,000 years, and then 1,000,000 years, that's the beginning of humanity. So very quickly in these decades of time, we go much more primitive than we have now. Let's just reverse this and go out into the future by 10 years. We might confidently predict genetic engineering and really be able to anticipate the world in 10 years. In 100 years, we may well have fully cybernetic organisms, artificial intelligence that truly rivals our own. I think that's a fair prediction. And as an astronomer, I do hope and speculate that within 1,000 years, we will be traveling to the stars. But that's only 3 decades of factor of 10. And we have to imagine civilizations that have been around and are ahead of us by millions of years or even billions of years. And I simply don't think we have the ability to predict a nonlinear exponential trajectory of our civilization even 1,000 years in the future, let alone 10,000 or 100,000 or 1,000,000. Another way of putting this is to make an analogy. Microbes have been on the planet for 4 billion years, and they're still here. They're the dominant form of life on the Earth. To go from microbes to us was about 1 billion years. So from microbes to us is as we are to what? What in 1 billion years of evolution would humans turn into? Can we even imagine that? And then the technology. Tools, basic rock tools of tens of thousands of years old to the iPhone is as an iPhone is to what? What would 10 or 20,000 years more evolution of our technology look like? Can we even imagine it? And if you want to be literal about the gaming analogy, just take an late 70s, early 80s video game and compare it to Sims or a more modern game, and then say, what would another 40 years of evolution of video games be like? Can we imagine that? We're getting to a core issue. It's a core philosophical issue of what is the nature of sentience? What is the nature of our consciousness that makes us special, that makes us know who we are? We're asking really, what is real?
Try to relax. This will feel a little weird.
This is the construct. It's our loading program. We can load anything from clothing to equipment, weapons, training simulations, anything we need.
Right now, we're inside a computer program?
Is it really so hard to believe? Your clothes are different, the plugs in your arms and head are gone. Your hair has changed. Your appearance now is what we call residual self-image. It is the mental projection of your digital self.
This isn't real.
What is real? How do you define real? If you're talking about what you can feel, what you can smell, what you can taste and see, then real is simply electrical signals interpreted by your brain. This is the world that you know. The world as it was at the end of the 20th century. It exists now only as part of a neural interactive simulation that we call the Matrix.
So let me introduce you to something called the simulation argument. Now, it's an argument about our status as humans and sentient beings, and it applies in the world of astronomy and other worlds. But this is an argument that came from philosophers, and it's literally based on probability theory and logic. According to the simulation argument, one or more of the following propositions must logically be true. The chances that a species at our level of development can avoid going extinct before what's called technological maturity are negligibly small. In other words, we're doomed. 2, almost no technologically mature civilizations are interested in running simulations of minds like ours. 3, you are almost certainly living in a simulation. Let's deal with the technological maturity issue. That means the capability of an advanced civilization with advanced computational powers to replicate the behavior of minds like ours. We can imagine this by simple extrapolation of a century of computing, and you see it here in terms of computing power per unit price against time, going back to the very first computer. And you can see that depending on how you project this, you're getting to a level of human intelligence in 20 or 30 years. You can also notice along the right-hand side vertically the equivalent cybernetic organisms or robotic creatures for our computation, if we put the computation in package with sensors and allow it to live in an environment. Reading across from 2020, these capabilities are about the same as a lizard or a guppy, and that's about right. The best robots we have are not that impressive. But play it forward another few decades, and you get to human levels of capability. And so that dot on the upper right is a projection based on the continuing Moore's law, which will happen through quantum computing, and 10,000 processors working for a year, which we think could happen in 2050. In other words, it's a fairly small extrapolation of our current capability and trajectory to get to what we call an ancestor simulation. What is an ancestor simulation? It's a simulation in a computer of the entire mental history of all humans who have ever lived. And here you can see numbers put on it. Typical human brain in terms of electrochemical network has about 10 to the 17 maximum operations per second. And so the number of computer operations required for an ancestor simulation is about 10 to the 32. That's the maximum number. And you can do the math below. 100 billion humans, of those who have ever lived, 50 years per human, 3 million seconds per year, times the operations per brain per second. And so we're saying that within a few decades, a computer could simulate the thoughts of all humans who have ever lived. It's a remarkable proposition. And from it stems the simulation hypothesis, that any advanced civilization that did this could create simulated entities that would, of course, not know they're simulated and living in a simulation, leading to the hypothesis that for every non-virtual early 20th century human life, there are many more subjectively indistinguishable or broadly similar virtual lives. This argument assumes what's called substrate independence, the fact that the brain doesn't depend on being in the squishy biological casing of your skull, but could be non-carbon based and purely computational. That's an assumption. And in the three ideas underlying the simulation hypothesis, there's a presumption both that creatures that are capable of this don't self-destruct before they get to this capability, and that none of them who have this capability would choose to use it to simulate creatures like us. Well, we make video games better and better every year, so we're clearly not in that category. So the simulation hypothesis ends up concluding that there are more virtual creatures in the universe than there are real. Now immediately, most people have a reflexive reaction against this. I'm real, of course, you think that. Your conviction that your life is non-virtual is no better founded than anyone else's. Everyone else thinks that among the virtual reality creatures. So if the simulation hypothesis is true, the odds of your life being non-virtual are actually low. It's a kind of Copernican hypothesis. Basically, the idea is that it's so computationally cheap in terms of energy or computational power on this exponential trajectory. It's so cheap to create virtual civilizations in a computer that the odds that you're a real civilization, real biological creature, are small because the virtual ones far outnumber the real ones. And so If the simulation hypothesis is true, with high probability, then the likelihood that your life is real becomes a low probability conclusion. It's an extraordinary idea, and it amounts to another Copernican shift from real to virtual when we consider the sum of all lives in the universe. So that's a wild idea to finish with, and let's give the last word to a remixed version of the iconic astrophysicist and science communicator Carl Sagan.
I'm not very good at singing songs, but here's a try. If you wish to make an apple pie from scratch, you must first invent the universe. Space is filled with a network of wormholes. You might emerge somewhere else in space, somewhere else in time. The sky calls to us. If we do not destroy ourselves, we will one day venture to the stars. A still more glorious dawn awaits, not a sunrise, but a galaxy rise. A morning filled with 400 billion suns. The rising of the Milky Way. The cosmos is full beyond measure of elegant truths, of exquisite interrelationships, of the awesome machinery of nature. I believe our future depends powerfully on how well we understand this cosmos, in which we float like a mote of dust in the morning sky.
But the brain does much more than just recollect. It intercompares, it synthesizes, it analyzes, it generates abstractions.
The simplest thought, like the concept of the number one, has an elaborate logical underpinning. The brain has its own language for testing the structure and consistency of the world. A still more glorious dawn awaits, not a sunrise, but a galaxy rise. A morning filled with 400 billion suns. The rising of the Milky Way. The sky calls to us. If we do not destroy ourselves, we will one day venture to the stars.
For thousands of years, people have wondered about the universe. Did it stretch out forever, or was there a limit? From the Big Bang to black holes, from dark matter to a possible big crunch, our image of the universe today is full of strange-sounding ideas.
How lucky we are to live in this time, the first moment in human history when we are, in fact, visiting other worlds. A still more glorious dawn awaits, not a sunrise, but a galaxy rise. A morning filled with 400 billion suns. The rising of the Milky Way. A still more glorious dawn awaits, not a sunrise, but a galaxy rise. A morning filled with 400 billion suns. The rising of the Milky Way. The surface of the Earth is the shore of the cosmic ocean. Recently, we've waded a little way up, and the water seems inviting.
And that's the end of this module, and that's the end of this course. Thank you for joining me on this journey.